Hi boys and girls, it's me Butch. Butch News is on the air. Today is May 7th, it's a Monday, 2018 in Vancouver. My name is Butch, Terry David Silvercloud. I use all my names, but most people call me Butch. Today I am going to try to explain to you a theory about the cause of the speed of light. There is no known cause for the speed of light except the theory which I will attempt to present to you. I'm a bit ADHD, so my mind wanders a bit. I don't have a script. I am going to just talk and not exceed 15 minutes. So bear with me and I will teach you a theory about the cause of the speed of light, and you may learn a whole lot of other things as well. Let's talk about theories first. A theory is an idea that has not yet been proven. In the world of physics, there are a lot of false equivalencies and fallacies of ambiguity. A fallacy of ambiguity is where somebody takes something and presents it, they misunderstand it, and they present it in a somewhat different way because it was a bit ambiguous to begin with, and that's how a lot of the many false ideas about science that are out there begin. A false equivalency is where people use a term in a manner which has nothing really to do with it. And one really common one here, I'm going to try and get this up in front of the camera, there, is the term quantum leap. A quantum leap is the very, 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 very smallest leap you could ever possibly make. And I have to look at the camera here. This is a really crappy drawing of an atom of oxygen, and in the center is a nucleus, over there somewhere. And around it, sort of like in onion shell type layers, you will find the electrons. Electrons don't fly around in orbits. That idea was given up years ago. They exist at certain distances from the nucleus, and at any given moment they'll be in a certain area, and it's always hard to tell exactly where they're going to be. But they are always at a fixed, generally sort of a fixed distance from the nucleus, and they occur, the numbers that can be in each level of the shell or subshell is fixed. It may be full or it may only have a few. So when an electron wants to go from a lower level to an upper level, it needs to acquire energy. And if it makes that amount of energy, if it acquires that amount of energy for some reason, or jumps out of its outer shell into free space, that is called a quantum leap. And it's extremely tiny. It's the smallest measurement you could think of, and it takes about a quantum of energy to do that. And when the electron breaks the sound barrier, it'll leave behind an amount of energy called a photon. And there's another one that's totally misunderstood. Photons are not light. Photons are a unit of measurement. They're used in quantum physics, and they're really handy on a blackboard for calculating things. But it takes a truckload of photons to make even a tiny bit of light. It's just a unit of energy. So that's a false equivalency. Also in the world of physics, anything smaller than 1 micron immediately falls into the realm of quantum physics these days. And that's causing a lot of problems, because when you want to study things that are smaller, it becomes very difficult. Particles aren't allowed, and like solid things. They just don't exist. Everything becomes a wave. So it kind of limits people like me who like to work at the atomic level and the subatomic level of reality. Another, I had a drawing here and I lost it. Oh, that's what I was going to do. See, I have ADHD. What was I going to talk about? See, I even forgot what I was going to talk about. Let's get back to something I was talking about, and I'm up to 4 minutes already. There's a lot of problems in the world of physics, and Lee Smolin, who was a leading string theorist and abandoned it for quantum physics, wrote a book called The Trouble of Physics. So if you want to learn about what's wrong with physics or going wrong, you should read the book The Trouble with Physics by Lee, L-E-E, Smolin, S-M-O-L-I-N. I've read it. It's a good book. It's probably out of print. So in the world of physics, we have theories and we have laws and facts. The laws are things which we've proven over and over and over again. They work, and you'd be hard-pressed to disprove them. Darwin's theory of evolution has been tested so many times that one would be foolish to believe that it's not pretty much correct. Big Bang theory is so full of holes that only a brain-dead type would believe it. It was a bad idea to begin with because it didn't explain what came before, it didn't explain what was outside. It required just to exist breaking most of the basic laws of physics. And fortunately in 2017 a massive black hole was found at a distance so far that it could not possibly have been there and Big Bang have happened. It's pretty much if you needed a definitive final proof that Big Bang is just a silly creationist theory by some God-fearing kind of person who likes beginnings and endings and can't deal with infinity, you're going to have to learn to deal with infinity if you wanted to get into physics. There is no end to anything. It just goes forever. Since I'm ADHD, and I'm already up to 6 minutes now, let's talk about how big is big, how small is small, and time. Isaac Newton, way back when, who wrote most of our basic rules and laws of physics, he recognized that absolute time, we have nothing with which to measure absolute time, and that we would be stuck, at least as far as he knew, with relative measurements. So way back when, Newton realized that if we were going to talk about something happening, and Einstein would be the same way, as if we're here on this page and we're going to predict the future, we have to sort of have an idea where this is going, and all we can do is predict what's going on in here when it's over there, but it doesn't allow for anything out here. What was I talking about? See, that's the trouble with this ADHD thing. So we're going to talk... I am assuming you have some basic understanding of physics, and I'm going to keep things really simple. Science is basically simple. If you want to work in physics, you're going to have to learn how to do calculus, because you're going to have to learn how to solve problems. So if you want to practice physics, you're going to have to learn how to do some really difficult math for some people. Differential equations and things like that. But basic science doesn't require a whole lot of math, or just really simple math. One of our most famous scientists, Michael Faraday, he was a bookbinder, and he liked science. He had a basic high school education, and he didn't make a lot of money. And one day a patron gave him a ticket to a lecture by Sir Humphrey Davy, who was the Queen scientist. And, they didn't have movies, so a lecture was a big deal and expensive. So Michael went off to the lecture, and he wrote copious notes about the lecture, and then, being a bookbinder, he bound them in leather and he sent them off to Sir Humphrey, and Sir Humphrey was so impressed he plucked Michael out of the bookbinding job and got him working on trying to figure out what's this electricity thing, and why are the iron filings doing all that. And Michael Faraday gave us most of our basic electrical laws. He just had a high school education, and his math skills were getting better as he went along, but it just required basic concepts, like how things work. And I'm up to 9 minutes. I gotta get really fast here. So how big is big and how small is small, and what is time? Time is always relative. We started by measuring the sun going up and down, and now we have atomic clocks. How fast is fast? Well, it depends where you live. If you're on a carbon atom, which might be 150 to 200 picometers, trillionths of a meter in diameter, if this was a carbon atom here, and you were living on a carbon atom, you would be even smaller, so you wouldn't even be able to tell what light was. A red light wave would be bigger than your entire atom. So it would be like a wave, and you just ride over it. You wouldn't even know what light was if you lived on a carbon atom. So how big you are, or how small you are, really affects how one perceives things. Size really matters. Also, so I said I'm going to keep things simple. We're going to talk about the speed of light, and you will think of it as being really, really fast. And I don't know if you're going to go in miles per hour or what you're going to do, but I'm going to round it up just for simplicity's sake to 300,000 meters per second, so that we don't have a big long row of numbers. It's actually just somewhat slower than that, but it doesn't matter for the sake of what I'm talking about. I'm up to 10 minutes already. It's hard to imagine 300,000 meters or 186,000 miles in a second, but remember, time is relative, and it's relative to how big we are. And if you were living on a carbon atom, a better time frame for you might be, I don't know what that was, some sort of whistle. See, I don't know what that was. I live near the river. Hope nothing's going wrong. 11 minutes already. So a better way of thinking about time is a billionth of a second, which is called a nanosecond. And in 1 nanosecond, light just goes roughly that far a foot. 29.9, roughly 30 centimeters in 1 nanosecond. So now light is tameable. There's so much I could talk about, but I got to get directly to it. What does cause the speed of light? Okay, this is a theory. I told you it's a theory, and it's not been proven, but there are tests you can do, and I don't have time for that. I'm working on writing the theory out, and I will leave a link to that, and eventually I will get all the spelling mistakes out and a few addendums that I'm adding to it. So, something you need to know about the speed of light, if it's direct current, oops, I have a piece of tape on here too. Should have taken that off earlier. Oops. This is just a tube full of marbles, and you may think of it as a wire full of electrons. And although I'm having trouble pushing them through, I can push marbles through here. So here is a little marble. Can you see it? This is an electron. So electricity could go from here to there at the speed of light. We're not going to tell you how that is. It doesn't matter. Whether it's a mile long or a foot, doesn't matter. Electricity is going to travel at the speed of light, but the electron isn't really traveling as fast. In direct current, if one electron goes in this end, at the speed of light, another electron came out at that end. And so on and so on. So the electrons don't have to move very fast. And if it's in an alternating current, it needs only go to its diameter and back, or to rotate completely once. So in an alternating current, the electrons don't really go anywhere. I'm up to 13 minutes. In direct current, it's one in, one out. So when you're going to measure things, you need a smallest unit with which to measure it. And in quantum physics, by good fortune, the electron is the standard. That's really handy, and one of the reasons it is it's the smallest physical particle in the universe when you think about electrons, protons, and neutrons. If this is a proton, this is an electron. They smash these things to try and find out what's going on, and everybody ignores these little tiny things, which we use all the time to even measure the actual smashing. Nobody's paying attention to the electron. If light travels, 13 minutes, 14 minutes already, I might go over 15 minutes. If light travels a foot per nanosecond and it's 3 feet from my finger to my brain, it will take if I touch something hot, it'll take 3 nanoseconds to reach my brain up here, and I'm usually stoned out of my tree anyway on pot. I don't get stoned, but I take a lot of painkillers. And it would take another 3 nanoseconds to get information back to the muscles to get out of there if it was hot. Information could not reach my brain except by way of the electron. It just could not get there. And if you start thinking about the idea of one in and one out, You can see on one side there's a space between the balls, on the other side there isn't. If you start thinking of the universe as obeying the laws of buoyancy, and whether you believe in dark matter or not, there is energy in space in terms of electromagnetic waves. Even if you don't believe in a medium to make the waves happen, the waves are there and we know they're there. So if one electron in and one electron out applies, even with the ones with the space between, the electron need only move one of its units to push stuff out of the way, and everything else would have to get out of the way. That's why I believe that gravity is push, not pull. Everything's trying to come to rest. And in this really fast-moving universe, and you're moving at through the galaxy at 230 kilometers per second, we're moving really, really, really fast. Nothing can ever actually go in a real circle because of the way we're going forward. And the path of the Earth is actually a helical wave through space. There is no circles. You can't make a circle except drawing it on the surface of something else, which is making the wave. There are no actual absolute circles. And I'm over 15 minutes, 60. Oh, well, let's just see what happens. So getting down to the speed of light, in this theory, it doesn't matter really whether you believe an electron is a sphere or what it is. In my world, an electron is an icosahedron. An icosahedron is 20 tetrahedrons, all with their apexes at a singularity, which is very handy for quantum physics, because all you need to do is to track the center of the electron, which is what they actually do in quantum physics, because they think of it as a wave anyway. It's just going here or there, whatever it's doing. What else do I need to tell you here? So in this theory, it doesn't matter whether you care about the shape, but what the theory is about is the speed of light is set by the actual physical size of the electron. The electron is a particle. It has solidness in all worlds of science. And in quantum physics, in order to be here and there, you cannot, even in quantum physics, be here and there unless your inertia and all energy is zero. You're at the dead center of this sucker. And then the unit of measurement around which everything is measured is a wave the size of an electron, and they have measurements for that. So we already the unit of measurement we are already using, except nobody's stopped to think about it except apparently me. This is what sets the speed of light. Even if there was something traveling faster than the speed of light, it still has to get past this sucker. And if it's smaller than this sucker, it'll push it, because it's like water and things. The universe should be thought of as being a sea, and the physical objects all obey the law of buoyancies. For an electron to be here, there, and fill this entire void at the same time, to be a singularity, which did not occupy space, but it does occupy space. Hope that doesn't turn your mind to rubber. For it to be here and there, it would have to, as a singularity, exceed the speed of light. And it's quite easy to determine how fast that would be. The formula for a volume of a sphere is 4/3 pi r cubed. So if you replace the radius with the speed of light for any given amount of time, you can tell in our relative time frame of a second how big that would be for a given length of time by just changing the formula to 4/3 pi c cubed. You'll notice that sounds a lot like E equals mc squared. And the reason Einstein came out with the squared was he was dealing with forces. He wasn't dealing with the totality of the force. When you're in a blast, if you want to blow this microphone over here, you want the blast to come from here, and unfortunately you can't really make use of that blast except to maybe it'll help propel this blast to where you want it to do some damage. So if you look at the E equals mc squared, it's really just a formula you know, when you're looking for the area of a circle, where you take the, I've done sort of the same thing, taking the radius and changing it to the speed of light. Same idea, but to be here, there, and everywhere within this sphere at a given time, you would have to travel at 4/3 pi c cubed for the given amount of time it would take to do that, which for an electron would be our standard of time, which becomes our absolute. It's not a real absolute because we don't know what absolute is, but it would be our absolute, and a pretty good relative one at that. And now I'm up to 20 minutes. I'm going to see if this will upload. It might not. I may have wasted my time, but this will have been a good exercise to try and make a video about that. I did not cover everything. Did I cover everything? No, I didn't. But it's because I don't have a script and I don't know where to begin and end. The basic premise of all of this is that the speed of light, the clock, the bit that makes the bytes, that gets information to here, because your whole reality is really in here. There's no light out there. There's just electromagnetic energies. You have eyes that have antennae, which are rods and cones that are approximately 1 micron long, which happens to be the bandwidth of light. And any wavelength within that bandwidth will cause those rods or cones to vibrate and generate electrical impulses, electrons at the base of the nerve. It's sent to the brain. So nothing gets to your brain anyway except by way of an electron, and your brain can only process about 10 images per second. That's why animation is at least 12 frames per second and film is up to 24 frames per second, so you don't have any jitteriness. Your brain can only, unless you're very, very young and have a good brain, once images repeat them faster than 10 frames a second, it just seems like continuous motion to you. So I'm going to put a link to my theory about the cause of the speed of light. It's not updated yet, and eventually you can download the manuscript, the first public. It has spelling errors and stuff. I don't have spell check in this little thing here. I now have a anyhow, I'm not going to tell. I had my issues with my broken little power book here, but what am I talking about? I will post links if you want to read more about the whole gist of this entire long video, aside from trying to teach you a bit of science and open your eyes to the fact there's a lot of bunkum out there that I see. I have my ADHD. It's hard to live with. I will post links to the theory, and I'm going to shut up now because I never shut up. I'm known for yak, yak, yak. My name is Butch, and I'm posting this at Butch News on my YouTube channel. I don't do much of that anymore, and I hope the sound's working. I had some issues, but I think I got it fixed. Bye-bye from